Hello students, welcome to JEE English by Unacademy, India's leading and largest learning and test preparation platform. Guys, we have made this JEE English channel for you so that we can deliver content exclusively in English for your competitive exams. And it is the nationwide, the first channel that delivers content exclusively in English taught by experts in this field. We have a bunch of IITians who are teaching on this channel and they know what you need to do to get through your competitive exams. Guys, today we are going to get into kinematics. We are going to explore kinematics, and as usual, we are going to tear apart this kinematics and understand every bits and pieces of kinematics. But when we are talking about kinematics, what is it? It's the study of object in motion. But what is this motion? We will understand this as and when we keep moving through this lecture. And let me give you a hint. So let's say you are on Earth and you're observing your neighbor. Okay? There are two people who are sitting on the chair. One is you and the other one is neighbor. Then you are going to say that your neighbor is in rest. And similarly, your neighbor is going to say that you are in rest. What if, like I told you, someone from the moon is observing you? Or someone from some other planet is observing you, where the planet is moving with different, like momentum. In that case, that person is going to say, hey, you are moving. And you are as well going to say that the person on the moon or the other planet is moving. So I think you must have got a little bit intuition of what is motion, but we'll understand it more, more conceptually and using more theories and more of intuition, like what it is. You will be able to perceive it in your real life. And guys, let me tell you a little bit about myself. I am Murlidharan and I completed my MS in Electrical Engineering from University of Colorado Boulder. And I'm an IITian. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. I have filed 18+ patent applications in India, US and Canada. And guys, I am here to teach you physics. I'm very passionate about physics. I want to make sure you understand every bits and pieces of physics and become passionate about physics and understand how to apply this in your real life. And I want to make sure you get better than me, guys. That is my objective. You get better than me, you understand concepts better than me, and you challenge me in physics with your conceptual strength. Alright guys, Unacademy and myself have something interesting for you. That's our Unacademy learning app. You can go on to Google Play Store or App Store and download our app and attend our free special classes where our top-notch educators come onto this platform to teach you. And if you're looking for some test preparation, structured learning, you may want to go on to our subscription platform and subscribe according to your program. If it's IIT JEE, get to the IIT JEE, or if you have some specific program that you are preparing for, get on to that program and you can get our subscription and also get a 10% instant discount using my coupon Muralidharan. And if you're looking for, like a 24 months preparation, if you're in 9th, 10th or 11th class, then you may go for like a 24-month subscription, which hardly costs 1,500 per month. And if you're long-term or dropout, you may want to go for a 12-month subscription, which also costs hardly 2,500 per month. And if you're in lockdown, if you're looking for something where you can have, n number of materials to prepare for your exams and get some structured learning, get some live quizzes. So see, the specialty of this platform is not just about, live learning, but it also has, doubt clearing sessions with the experts. And not just that, we have tests, live tests where you can assess yourself. So it's a competitive exam, right? You have to assess yourself with the rest of them. But, it's not all about competitive exams, guys. It's about learning. And you should not be afraid of things. Do not be afraid of things. Be not afraid of trying anything new. Do not be afraid of failures. You should go for it. You should go for it. You should try for it. If you don't try for it, you don't know whether you can succeed or you may not succeed. So it's all, a perception, and success is not everything. You have to fail, and then you'll succeed someday. So that's the concept of success. And if you succeed well, in your first attempt or something, that's great. I mean, that is the entire objective of life, isn't it? And the objective of life is to try things. Don't be afraid to fail and try things. This is told by one of the best athletes in the world, Michael Jordan, whose record has not yet been broken, even by basketball players today who are working, on novel technologies. We're working on the techniques using novel technologies. So that's the starting gist of the class. But before this, let's understand, we had few doubts in the earlier class. So one of the students asked me, what is direction? Okay. So direction is something where you have to travel towards, or you're observing something and that is traveling towards. For an example, let's say you have to travel from ear to ear. Then for you the direction is this. You have to travel this way. And let's say you are this and you want to travel towards this destination. Then the direction is this. Put yourself in the shoes of the person who's going to travel or an observer who's observing an object. So that will tell you the direction. So direction is just normal intuition, like what you're thinking about. Direction is the way you want to travel towards. And it's basically what you would do is you would subtract the vector between the final position and the initial position to know it, or we can make use of angle theta with x-axis, or like an tan theta to understand the direction. And we learned that tan theta explicitly does not talk about direction because there are some issues in that. So that being said, I guess you understood direction now. Direction is the way towards which you want to travel, or the way towards which an object you are observing is traveled with respect to you. So direction only makes sense as long as there is an observer, or there is a relative thing. Like, there should be like two relative points or something. Else direction does not make sense. And the next question was, I guess, does, sun is sun stationary? I guess it is something like this. No, I mean, like, sun is not stationary, sun is moving, sun is revolving around its own orbit, and sun is also rotating around its own axis. If someone has told you sun is stationary, it's not stationary, guys. It is moving. Okay? Just like how earth is moving, sun is also moving. If at all we said, earth and sun are rotating in this, in the same axis with same area, and and they're up and down, then in that case, what would happen is you would also with the same angular velocity in the same direction and with the same axis of rotation with the same rotational velocity, then you may call it stationary from your perspective. Still, for a person outside this entire system, he's going to call it's not stationary. Okay, you got this point, I guess. Now the next question was, what is tensor? So this is a very interesting question, guys. Listen carefully. So in a scalar you have magnitude. In a vector, you have magnitude and direction. In a tensor, you have magnitude attached to a direction along with an area. Okay. So, in a tensor, you have a magnitude with direction attached to an area. For an example, stress tensor. So, stress has a direction, but it needs an area. It cannot alone work on the direction and magnitude. So, scalar is a zero order tensor and vector is a first order tensor. And now the thing is, you need to understand tensor is one where it has an additional direction attached to it. An additional thing known as area attached to it. You need to be very careful about this point. Stress and strain are some examples of tensor. I'll repeat it again. Tensor is actually a physical quantity, just like scalar and vector. I mean, it's one of those categories. So, tensor is a physical quantity where it has direction, magnitude, and also an area attached to it. Examples, stress and strain. So, I think that's about all this doubts, guys and students. Now, let's get into the concept of today to understand motion. Okay, that is all kinematics is about, right? So, but to understand motion and to define motion, first let's, I'll brief you through this concept of velocity and speed. So you remember this, like speed is something where you are measuring it, but it does not have any direction, whereas velocity has a direction attached to it. So when I'm talking about direction attached to it, that means velocity is a vector quantity and speed is a scalar quantity. And what is that thing you're observing on the scale? That's instantaneous speed. Speed at the moment, speed at the instant is what you're observing on the scale. And how do you find out speed, the value of speed? Just divide the distance by the time. And for velocity, you take displacement. And so there are two kinds of things that we generally talk about when you're talking about either speed or velocity. One is average speed, the other one is instantaneous speed. Instantaneous speed is the speed at that instant where, let's assume, I'm more delta d direction, like a very little bit of direction, and then you call that thing as the delta D as the distance that has been moved, and then you, according to the delta D, you will take a delta T. Actually, I should have said it the other way around. According to delta T, you will take the delta D. So let's say in a small time frame, you measure the distance moved, then you take this distance by time, then you will get the instantaneous speed. Similarly, for instantaneous velocity, you will take the small time frame, that is, you will assume that the limit of time tends to 0, and then you will calculate the ratio of that displacement by time. Hope you got it. And what is average speed? Very practical thing. Instantaneous speed may not be very practical thing. It tells you the target, like this is how much I have to move so that I can reach my destination within this point of time. Whereas average speed talks about total distance by total time, like how you see on your, like any maps or any, information given by a friend. Rather not even maps, any information given by a friend is a more accurate representation of it. So you would say, you know what, I started today 6 a.m. and I reached 8 a.m. I think it takes 2 hours, and you know the distance, then you calculate it, okay, this is the speed, this is the average speed. So that is more of like an average speed, more of a practical thing. And what about average velocity? Displacement by total time. So there is no, you are not going to call it total displacement, just the displacement. That means the, the length of the path between the final point and the initial point. Okay. If someone is talking about total displacement by total time, that also means it is displacement by time, because there is no meaning of total displacement. So what they are trying to mean over there is they are trying to add these individual displacements. So it's a vector quantity, right? Once you start adding them, the entire quantity will come to displacement. It's really that simple, guys. So you need to understand these two concepts when we are moving into motion, and especially you need to understand what is the difference between average speed and instantaneous speed. Why instantaneous speed is important? Instantaneous speed lets you set the target, whereas average speed gives you the realistic estimation. The same goes for average velocity and instantaneous velocity. So in a circular motion, you are seeing that, the speed is constant, but the velocity is changing, and as well as the instantaneous velocity is also changing. Even though the speed is constant, the direction is changing. So the instantaneous velocity is changing. So that being said, we'll get into, the core of the concepts. But before that, we'll have a look at some, problems or, concept where we are calling it like average speed, and like any misconception around this problem, around this concept will be cleared once we go through this kind of problems. So this is like a relationship that we develop. So let's say there are like, multiple speeds for multiple time frames. S1 in time t1, S2 in time t2, S3 in time t3, and so on till Sn in time tn. So this car over here, the car you see over here, is moving with speed S1, S2, S3, so on, and it is changing with respect to time. For time t1, it is moving with speed S1. For time t2, it is moving with speed S2. And for time t3, it is moving with speed S3, and so on till Sn. So, like our, general intuition is going to say, let's just add the speed and divide the time. But that is something that you should not do. Even if you match the units, it will go wrong. So work around the units and dimensions. So this, I told you, right, like the units and dimensions of the physical world is also an important topic to understand how to solve the problem. If you just keep on adding the speed and divide it by time, will the units match? Or will the units change? Well, this point gave you a natural intuition around this physics. So when we are talking about total, like average speed, we are concerned about total distance. So what would you do? You will count each of these distances within each of this time frame. So let's say, for time frame 1, that is like for T1, sorry. For T1, just a moment guys, I'm just picking up another color so it's more visible. So for time T1, the object is moving with speed S1. So distance would be within the time T1, S1, T1. And for time T2, it is traveling at speed S2. So the distance D2 would be S2, T2. And for time T3, it is traveling with a speed S3. That means the distance would be S3, T3. So what would be the total distance in this case? The total distance would be S1, T1 plus S2, T2, S3, T3, so on till Sn into Tn. Okay. So you got this point, I guess. So now we found out total distance. The next thing is you'll add all this time, this total time, and that is like finding out the total time. You'll add all this total time and you will divide this quantities. Like, you'll divide the total distance by total time. And this will tell you about the average speed. Just like what is written over here. Like average speed is equal to S1 T1, S2 T2, S2, S3 T3, so on till Sn Tn by T1 plus T2 plus Tn until T, it should be Tn. This is Tn. Okay, whatever, you understood the concept now. Now let's do a problem around this so that we get more of a conceptual clarity. So now let's say a car is moving for first hour. That is the first hour at a speed of 30 km per hour. Okay. And now this car that you see on this, left, that one jumping, humping, that is moving with 30 km per hour for the first hour, and for the second hour it's moving with 60 km per hour. So the speed is changing with time, and it's not even a uniform time. For next 1.45 hours it's moving with 40 km per hour, and then followed by 2.5 hours with 80 km per hour. Okay, now they have given us very different times and they have given us very different speed. Answer is very simple, you know it now. You have to multiply all this time with speed and you will calculate the answer. So for the first hour, that car must have traveled 30 kilometers. For the second hour, the car must have traveled 60 kilometers. Second hour, not for 2 hours, it's second hour. And for next 1.5 hours, it has traveled with 40 kilometers per hour, which means it has traveled 60 kilometers. So 60 plus 60, 90, 90 plus 30, 120. So far it has traveled 120 kilometers, followed by 2.5 hours, in which it has traveled with an 80 km per hour speed. In 80 km per hour speed, it is going to cover 200 kilometers. So it's 2 into 80, 160 plus 80 into 0.5, that's going to be another 40, that is going to be 200. So 200 plus like 60 plus 60 plus 30. So that's going to be 350. 350 divided by the total time will give me the average speed. And total time would be 1 hour plus the second hour will be another 2 hours plus 1.5 hour, that's going to be 3.5 hours plus 2.5 hours, that is going to be 6. So total time of travel is 6 hours. The total distance covered is 350 kilometers per hour. So the answer is going to be 175 by 3 kilometers per hour. And guys, if the calculation, if the final result or the option is given in meters per second, do a thing, calculate this, which one is easy for you. According to me, calculating in kilometer per hour is easy, because in this case, everything is given in hours, and then convert it to see how the answer turns out. Because you don't want to convert it and make it messy doing this 5 by 18, 18 by 5. So in whichever units it is given, do it first and then, convert it. That will make your life very easy. So I guess this is just the solution. So we'll just skip through this part of it. And now the next question says, a car is moving for 50 kilometers with a speed of 50 km per hour, and so it's saying the car on the left is moving with a speed of 50 kilometers per hour for the first 50 kilometers. Then the next 120 kilometers, it moves with a speed of 60 kmph. And then for next 200 kilometers, it is moving with a speed of 40 kilometers per hour. And for next 160 kilometers, it is moving with a speed of 80 kilometers per hour. So now in this problem, it's not the same one. So it, you must have been, thinking it is somewhat similar one. Maybe like looking at this humpy jumpy, picture on the left of the car. But in this case, what they are talking about is, like, this car is moving specific distances with specific speed. So with distance intervals, the speed is changing. Okay. Now the key is you already have the distances. The total distance traveled by this car. Now what you need to find out is the time. Okay. It's really as simple as that. In the earlier problem, it was the car is moving with different speeds in different time intervals. In this case, the car is moving with different speeds in different distance intervals or in different distance limits. So in this case, what you do, you know the total distance. The first, numerator value is known to you. When we are talking about find the average speed, you know the numerator value. Now you need to find the denominator value. So how do you find the denominator value? You will have to find how much time it has taken to traverse each of this distance. So let's do that this time. So the total distance is very easy. So it's 50 kilometers, then it is 120 kilometers, and then it is 200 kilometers. So that's going to 320, 370, and then that is going to be another I think 160 kilometers, and this 370 plus 60. So that's going to be 430 plus 100, 530 kilometers. Okay. So this car has traveled in this entire journey 530 kilometers. You got it right? Now the total time. Coming to total time, how do you find out the total time? You know the speed, you know the distance, you will divide that particular instant, this interval distances by the speed, then you will get the total time in hours in this case. So 50 kilometers by 50 kilometer per hour, that's going to be 1 hour. 120 kilometer by 160 kilometer per hour, that's going to be 2 hours. And again, it is going to take 5 hours to complete this 200 kilometer journey with a speed of 40 kilometer per hour. So far we have completed 1 hour, 2 hour, 5 hours. So it's already 8 hours. Plus another 160 kilometers with 80 kilometer per hour speed. So that would be another 2 hours. So total 10 hours. Okay. So that is 1 plus 5 plus 1 plus 2 plus 5 plus 2. That's going to be 10 hours. And now you know the answer. It's 53 kilometer per hour. So this is the average speed. The A is the option. The correct answer. The A option is the correct answer. So now let's get into a very interesting problem, like a cardinal space or position space problem. So this is a position space problem. So see guys, most of your problems in talking about distance and displacement is not going to be like a cakewalk beat in any exams. They're not going to ask you, this is the given displacement and this is the given point, find out the displacement. They'll try to take you into the physical world. They'll try to make you think about the physical world. So in physics, it is very important that you try to imagine things. Tesla used to imagine the working of motors in his mind. When you can imagine about things, imagine about physics, imagine about how things work in physics. So let's get to this problem. The position of A in space is 30, 50. That is x coordinate is 30 and the y coordinate is 53. The position of B in space is minus 12, 11. Which means the B is in the space at a position of minus 12 x coordinate, that is in the minus x axis, and 11 in along the y axis, along positive y axis. And Shalini travels. So Shalini is a person who is traveling every day to office from B to A. Okay. She is traveling from B to A, which means she is traveling from this position B, okay, to A. Okay, that means she probably stays at A. So they have given that B to A. So you need to carefully read this point. This is something that you need to, carefully understand and highlight it or keep it in your mind. But quickly guys, when we are talking about exams, quickly you need to just skim through this point. And they are asking us to find the nature of the slope. So what do you do? Final minus initial. So it's going to be A minus B. Okay. So we'll do it in terms of vectors, or you can also simply do it in terms of coordinates given, just two positions. But if they have given you multiple positions and they asked you to find the relative slope or something, then you would have to work around vectors. So now it is saying that RA is equal to 30 I cap plus 53 J cap, which is the position of the A, which is the position of the office, and B is equal to minus 12 I cap plus 11 J cap, which is the position of Shalini. So it's going to be RA minus RB, and if you calculate this, 30 minus 12 of minus 12, it's going to be, 30 minus of minus 12, that's going to be 42. And 53 minus 11, we know it's 42. So it's 42 I cap plus 42 j cap. And now we know that vectors explicitly talks about direction. Like just like what we spoke in the beginning during the doubt clearing session, like vectors explicitly speak about the direction. So now when we find out the direction, we will have to also include not just the magnitude to find out the tan theta, but also you need to make sure that you understand that this is in which quadrant. So this thing is in plus x plus y quadrant. Okay, this is in plus x and plus y quadrant. And 42 means it's a 45 degrees angle. Tan theta is equal to 1. Okay, when the x and y magnitude is the same, then you can straight away say it's, you know, a 45 degrees angle. And it's traveling along xy direction, like along, you know, positive x, positive y direction. That means up the slope. Okay, up the hill in this case, I guess. Yeah. So theta is positive means up the hill. So 45 degrees up the hill. So it would be C. Now let's get into a very interesting problem around cardinal axis. So until now we saw problems on cardinal axis using distances or displacements or positions. Now they have started talking about velocities. If you carefully notice the problem, they have started talking about velocities. Now this car travels at 50 km/h towards east for 1 hour. Let's first understand the problem. The problem looks little bit, you know, big, too many directions, too many, you know, speeds, too many like time frames, but it's easy, guys. It's very easy. If you carefully notice the problem, if you carefully apply the strategies and techniques, it's very easy problem. So it's saying the car travels 50 km/h towards east for 1 hour. So the car is traveling towards plus x axis. East is plus x, north is plus y, and similarly the opposite direction for north would be south and for east would be west. So I'm going to add an I cap to it. So the car is traveling in 50 I cap km/h towards east. Okay, I mean sorry, for 1 hour or towards east. And then the car is traveling at 30 km/h towards north for next 2 hours. So the car is then going to travel at 30 km/h towards north means plus j cap. Okay. So 30 km/h means plus j cap. So 30 km j cap for another 2 hours. And then towards, you know, like west for 1 hour. So now what would you do? So what have they asked us? That is first thing that we have to look into. So they have asked us find the average speed and the magnitude of average velocity of the car in the current position. So they are asking us two things. One is average speed and the average velocity. For velocity, you need to find the length between final and the initial point. And for speed, you need to find the total length of the path. Okay. And remember this, keep, remembering this, or, even let's say you need to have this idea intuitively in your mind that when we are talking about velocity, it's about displacement. When we are talking about speed, it is about the total length. Okay. Now, the thing is, they have asked us like two things. One is average speed and the magnitude of average velocity. So that being said, first, we will understand it in terms of vectors. Our standard technique where we'll be writing cardinal axes in terms of vectors. So what I'll do is I'll do a thing. I'll find the final position using all these things, the information that I have, and then we'll initially calculate the magnitude of displacement, and we know the magnitude of distance from there. Okay, we know the magnitude of distance from there. So for first kilometer, for the first hour, it's traveling with 50 km/h like speed. We need to calculate the position. When we are talking about displacement, we need to calculate the final position. So that's going to be 50 into 1 hour I cap. Because it has traveled in 1 hour, it would complete 50 kilometers along x-axis. So it's 50 I cap. And then it is 30 km/h for next 2 hours towards north. That means you're going to do like a J cap, and it would be 60 J cap. So 2 hours, so it has moved 60 kilometers with a speed of 30 kilometer per hour, and then it is going to be 30 kilometer per hour towards west for 1 hour. That means it is going to move in the west direction, that is in the reverse x direction for next 1 hour in like in a distance of 30 kilometers. So it will travel like minus 30 kilometers for next 1 hour. And we know we need to just find the position. We are not concerned about speed. Just remember that when it's a game of just time and like speed, you are not concerned about speed. Okay, and similarly when they have given you like the specific distances for specific time, then you are just doing the normal thing where you know the total distance by total time. So now the final position would be 50 I cap plus 60 J cap minus 30 I cap due to the west direction travel. So that would be like 20 I cap plus 60 J cap. And the final displacement would be, so we have assumed the initial position was 0, 0. Okay, that's when we were like able to confidently write this. Even not, it does not matter, you will subtract it. You will subtract that, like the final position from the initial position, and those coordinates will move away. So it would be like 20 squared plus 60 squared, that is going to be 3000 under root of 20 squared plus 60 squared, that is going to be 3600 plus 400. That is under root of 4000. Okay, under root of 4000. And under root of 4000, take out the 400, just keep the 10 inside the root, then you would get it as 20 under root 10 kilometer. Okay, the displacement is 20 under root kilometer, but what about the distance? Distance, you are just going to add all these values without any direction to it. Okay, the first hour it's 50 kilometers, the second hour it is 60 kilometers, and the third hour it is another 30 kilometers. So 50 plus 60, 110 plus 30, 140. Okay. So 140 kilometers should be the distance. So that's what we did over here. So we did like, we irrespective of direction or without the consideration of direction, we have added all of them and we got 140 kilometers as the total distance. And now the thing is, we need the total time. Very easy. It's 4 hours. Because since the beginning, I have been talking on this problem where it's 1 hour, 2 hours and 1 hour. So it's 4 hours, total 4 hours. So the speed would be like how much? The average speed would be 140 by 4. That would be 70 by 2, that is 35. 70 by 2, that is going to be 35. Okay, total time is 4 hours. So the average speed is 140 by 4, that is going to be 35. And the average velocity was 20 under root 10. That means the average velocity is going to be magnitude. This is magnitude of average velocity without the consideration of direction. If I told you direction as well or given you in terms of I and J cap, then what you would do is simply, divide this by 4. Okay. Guys, carefully understand this. If I've told you just the velocity, not the magnitude of velocity, and given you options, or even let's say it's like a numerical problem where there is a blank I cap and J cap, then what you would do is you would take up this value, this vectorial value expressed in terms of unit vectors and divide it by 4 hours. So that would be 5 I cap plus like 15 J cap. But in this case we are talking about velocity, so that's easier. And magnitude of velocity, average magnitude of average velocity. We haven't spoke about the velocity itself. So that would be 20 under root 10 divided by 4, and that would be 5 under root 10 kilometer per hour. So the option would be, so see, this is a standard, like a thing or a recipe in any of your competitive exams or most of the competitive exams where they'll try to confuse you with similar options. They'll just even though the values will be correct, they'll just interchange speed, velocity with the same values so that you get confused. And there is a standard thumb of rule to do this. Okay. And I'll tell you about this in the next Confuse Me challenge problem. But now let's have a look at this. So see how they have confused us is, one is they have given this both values are equal. Okay. So you are intuitively calculating the first value, that is the average speed, and then in the rush you're also marking A. So that would go wrong. Okay. And in the next case, what they have done is they have given same speed and velocity. So this most of us wouldn't make any mistake, because we know, like, 5 under root 10 is not something that is going to come when we are going to calculate average speed. Because by the time you have already calculated average velocity, you are not worried that, that this would be the correct answer. So, this is also the wrong one. And now there are these two options where average speed is 35 km per hour and the other one is average velocity where it says 5 under root 10 km per hour. So this is the correct answer. And what they have done in the last one, they have interchanged the velocity with speed. So they are just confusing you. This happens a lot in your exam. See, this is a wrong option, but the values are similar, and what they have interchanged is the values. So how do we work around such problems? Keep your concept clear, you'll understand it. So we'll do this next confuse me challenge problem to understand this. Which of the following are true? So I've already given you an hint. This confuse me challenging problem is around this concept. Like, when they're trying to confuse you in exam with some sort of, like similar values, just interchanging the values of speed with velocity and velocity with speed, or even distance with displacement and displacement with distance, then you can keep your mind clear with the concepts to work on this. So it says that magnitude of average velocity is always equal to or greater than that of average speed. Is this true? Do you think this is true? I don't think this is true. And the average speed is always greater than or equal to that of average velocity. Okay. It says the value of average speed is going to be more than that of magnitude of average, more or equal to that of magnitude of average velocity. Is this true, guys? Probably this is true. This is true. Okay. This is correct. So now I'll clarify your concept. Like, when they're trying to confuse you in your exam, you can make use of this concept to find out this answer. I mean, like, to at least, get the clarity on the answer. So I told you that the average speed is always equal to or greater than the dot of magnitude of average velocity. That means the velocity in any case cannot be greater than that of speed. Because in speed we are measuring the distance, the total length or the total length of the path covered by time, which is always more than the shortest distance between initial and or the final and the initial points. Okay, guys. So the thing is, whenever you see an answer that is trying to confuse you, remember that speed has to have a more value. Like, speed is faster than velocity. Okay, this is some way that you can remember. Okay, but you travel along displacement, you get the fastest route. But the concept that has to be clear in your mind is displacement is always less than distance, or distance is always greater than displacement. That also means velocity is always less than that of speed, and speed is always greater than that of velocity. Okay. And it can be also equal if it's the shortest path that they are traveling in. Now, the next option is magnitude of average velocity is equal to that of average speed. You already spoke about it, so this is not true. So speed and velocity cannot be determined, cannot be compared, because velocity is a vector. So the earlier one we have compared the magnitude of velocity and we said this statement is always true. This is like a universal thing. But when we are talking about speed and velocity, they cannot be compared because velocity is a vector. Okay, they are like two different things. You are not going to compare directly speed and velocity. Whereas what you are going to do is you can compare the magnitude of speed and velocity, but you will not directly compare the speed and velocity. Now let's come to another challenge problem, guys. So it says, let's say this entire motion took 1 hour. Okay, this car is going to go through some motion, and this motion took 1 hour. Then what is the average speed and average velocity? So what is the value of average speed and average velocity? I think this question is without regard to the consideration of direction. This should have been magnitude of velocity. Okay, this is not magnitude of average velocity and magnitude of average speed. So let's see, what is this motion? Oh my goodness me, the car traveled 4 kilometers. So this is 2 kilometers Okay, this is 2 kilometers and this is another 2 kilometers. Now this car again traveled another 2 kilometers. Okay, so again traveled another 2 kilometers. So for the reverse direction, I'm going to make use of green highlighter. So another 2 kilometers. What is the value of average speed and average velocity? What is the distance between initial and the final point? So car started over here. Okay, and it completed its journey over here. That is 2 kilometers. So the average velocity, the magnitude of average velocity for this entire 1 hour journey is going to be 2 kilometers per hour. Whereas for the speed, it's going to be 2 plus 2, 4 and another 2 in the reverse direction. So that is 6 kilometers by 1 hour. That is 6 kilometers per hour. Okay. The answer is given over here. Average speed is going to be 6 kilometers per hour, whereas the velocity is going to be 2 kilometers per hour. We did this challenge problem so that there might be questions like this, in your exams, where they're just going to tell you it travels from A to B, then from B to some C, and this is in this direction. They'll give in terms of east, like cardinal directions, like north or something like that. And they will try to make sure that, whether you understand the concept of average speed and average velocity or speed and velocity. So that's the thing, guys. So when this car is traveling in the reverse direction, we are subtracting it for average velocity, whereas for the speed, we are accounting the total length of the path. Okay. So guys, this is a very, 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 very important concept. I want you to stay attentive and understand this concept. Because this kinematics or even any kind of motion is mostly dependent on this concept. Okay, this concept is something that you have to grasp and keep it in your mind. You cannot go wrong in this concept. Okay, guys. So here is a situation where you are one of these persons. Just imagine yourself that you are one of this person. Let's say you are the blue one. And there is your friend and the green one. And what is this blue and green? Different planets. Just imagine 2 different planets that are moving with some velocity in rectilinear direction. Okay. In a straight line path. I know that planet moves in all the circular motion. But just imagine they are moving in like rectilinear direction. So you and your friend are on different planets, blue and green. And you both are moving in rectilinear direction with same velocity. Okay. This blue guy and the green guy are in different planets. That is the blue planet and the green planet. Now you guys are moving with same velocity in the same direction. Okay. Now what would happen? What do you think is going to be happening? So you would observe, think about huge systems like planet. So in this case, you would see your friend as if he's not moving anywhere. And in fact, if you try to shake hands from this planet to that planet, you would be able to do it with immense coordination. So I guess you understood this concept. So if you and your friend are moving with same velocity, with same within the same direction, I mean by velocity means same direction as well, then in that case you are observing as if your friend is also not moving. Your friend is stationary with respect to you. So this boils down to the concept of rest and motion. So what is rest? Rest is a relative thing. Okay, when we are talking about velocity, rest is an absolute relative thing. Where if you don't have an observer, then there is no concept of rest and motion. Okay, without an observer or without a frame of reference, without an observer or without any coordinate axis, there is no concept of rest and motion. Rest and motion are relative terms. Okay. Just like the example that I told you in the beginning. Okay. For you, a person sitting on a chair right next to you and not moving around is in rest because you both are on the same frame of reference, the earth. We both are on the earth. So let's say I am sitting over here and you are sitting over there in a stationary position. That means both of us are in rest. Forget this hand's moving, but both of us are in rest. Okay. And similarly, for someone noticing us from another planet or like moon or something, then that person may see us as if we are moving, as if we are rotating. We both are stationary with respect to each other. And similarly, we would see that person on the moon as if that person is moving or rotating or revolving, whatever it is. So, rest and motion are relative things. You need to get this into the mind. Okay. And it is more about talking about all these directions and things. That is when this rest and motion concept comes into the play. Got it. But your mind is intuitively perceiving things. Your brain is very smart. You are very smart. You are trying to think things from the facts. You know that the bus, like a person on the bus is not moving because you already perceive that the bus is moving and the person on the bus is also traveling, but maybe in the same direction. But what you know is like, okay, that guy is standing still or whatever, like a little bit of vibrations here and there. So you are perceiving it that way. But when you write it down in terms of velocity or when you mathematically represent things, that you know that that person is moving. Even if you take, like the concept of physics, that person is in motion. Because you are a stationary observer standing at the bus stand, observing that person in the bus. You see that bus moving at certain velocity, that person is also moving along with the bus, right? So that person is also moving along with this frame of reference or this object bus. So that person is also moving with that velocity or speed. But your brain is perceiving that the person is standing still for practical purposes because your brain is very smart, guys. So that is the concept. So in this end conclusion, what I'm trying to state is rest and motion are relative things. For two people in the same direction with same speed, and they wouldn't observe each other to be in motion. They would think as if both are in the rest. And similarly, for someone who is also stationary and is seeing a person moving at certain speed, this person over here, the stationary person over here, would perceive this moving person as if it's moving. It's pretty intuitive. But even if you just take up the velocity, concept of velocity and speed, you would observe that, you would see that this person, this observer from the car would also see as if this person is moving backwards. The stationary person is moving in the reverse direction. These things only come into your mind, when the objects are moving at very high velocities, because at that moment your brain is messed up a little bit, because you must have noticed in your childhood you are observing these trees on like trains, like the stationary trains outside the train, on the trains, that as if the trees are moving in the reverse direction. When you are traveling on a high speed frame of reference like train, mostly you must have noticed this in your childhood, that you are observing as if this, trees are moving in the reverse direction. Okay. And there is no concept of rest and motion without an observer. So there must be one observer, either some stationary observer outside, observing these two people saying that these two planets are moving. If there was no one, then no one knows that these two planets are moving. Okay. There should be an observer to say that these people are in rest or motion. Because if this person is the observer, he is saying that the green never moved. If green is the observer, then he would say blue never moved. So if there is an external party who is not moving, who is stationary, then that person would say, hey, these two planets are moving. So actually the observer decides whether the object is in rest or motion. So observer plays the most critical role in deciding whether something is in rest or motion. Okay. Now this is like an example, where a person is on spaceship and is seeing as if everything on the earth is moving. So if someone is on the spaceship, that person would perceive everything on the earth as moving. Like you would see, okay, everything in this earth is moving. My goodness me, what is happening? The earth has started moving. But the earth was always moving. So this is a critical concept, you need to understand this. Okay. So now there are these two people, A and B. Okay. They are standing on the train that is moving with certain velocity, constant velocity. Okay, that is moving with some constant velocity. And there is a person on the platform, stationary platform C, who is observing this moving train. Okay. So in this case, the person A never observes person B as moving. Okay, the person A would be able to shake the hands with person B with all the coordinations. But whereas the person C, if is trying to shake hands with A or B, then he cannot cordially shake the hands with A and B. The coordination would be missing for C, whereas A and B would be able to shake the hands. So the assumption is the person A and person B are at rest on train, but the train is moving. Whereas person C is standing on a stationary platform. Okay, let's go back a bit. So this person A is not moving on the train and the person B is neither walking or running on the train in any direction. So for them, they see each other in rest. They see each other like A sees B as if he is in rest and B sees A that A is in rest. And they would be able to shake hands or even do any kind of communication very smoothly. And once this person, the stationary person on on the platform sees them, he sees that these people are moving. Now for them, these people are moving. Like he sees not just the train moving, but these two people as well as moving. So you would not be able to, establish any communication so smoothly as A and B would be doing, who are moving at the same speed. Or even shake hands with the A and B. If C tries to shake hand with A and B, it wouldn't be, that coordinated. The reason is because A and B are in motion. Okay, but A and B are in rest with respect to each other. When A is an observer, he sees that B is not moving. When B is an observer, he sees that A is not moving. So both are at rest. Whereas when C is observing these people from a stationary platform, then he would see that A and B are moving. Okay. So this is the concept of rest and motion. I think you got it. So in this entire thing, for A and B, the frame of reference is this train. So that's the concept of frame of reference, guys. So in this thing, the frame of reference is the train. Okay, for A and B, they are in the frame of reference train which is moving. Even though the A and B are not moving, the train is moving. And for C, the frame of reference is the stationary platform. So that is frame of reference. The frame of reference is the frame or, from that particular system in which you are observing. Okay. So now let's do a thing. We talked all about this relative motion, frame of reference, etc, 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 etc. Now we'll solve some interesting problems, just using our basic concepts. And then we'll prove, then we'll derive how to work on this relative motion problems. So this makes our mind more and more intuitive once we go through this concept. So be attentive, guys. So I've been saying since the beginning that be attentive when I'm talking about relative motion. It's because it's a very important concept. And the next thing is, many of our technologies are dependent on this relative motion concept. Relative motion concept, frame of reference. And not just that, it's a very, an easy topic with high weightage. Many of our IIT JEE questions will be from relative motion. So be attentive, stay attentive, look at all these methods, how to solve the problem and solve it. It's a very easy one. It's not at all tough. Relative motion is a very pretty intuitive concept. Now let's start with the problem. So the problem says there is a grey car. So this is the grey car. So, and this might appear like, little bit different color. But anyway, this is grey car and there is a blue car. And this grey car and blue car are racing on a 10-meter track. Okay. They are racing on a 10-meter track. So it says it's a 10 meter. They are the start point. So this is 0 meter. They are racing on a 10-meter track. Blue has already completed 5 meters. Okay. And sorry guys, I'll just go through the question again. So it says that the grey and the blue car the grey and the blue car are racing on a 10-meter track. So there is this grey car and blue car which are racing on the 10-meter track. This grey car and blue car are racing on this 10-meter track. And they are moving with different speed. That is, grey car is moving with 1 meters per second. Okay. They are traveling in the same direction. They are moving with different speed. Grey is moving at 1 meter per second. I'm going to do a little thing over here. I'm going to mark the grey car speed with red. Okay. I'll do a thing. I'd rather make use of an highlighter, not an highlighter. I mean. So, grey car is moving with 1 meters per second. Whereas the blue car is moving with different speed, that is more speed than that of grey car. That is 2 meters per second. So, blue is faster. Okay. Now, the question says, blue has already completed 5 meters. Okay. Blue has already completed 5 meters in this race. So, how much speed is required by grey car in order to win this race? How much speed is required by the grey car? Okay. How much more speed is required by the grey car in order to win this race? Okay. So again guys, there are these two cars which are in race. Okay. Blue is moving faster than grey and blue is moving at a speed of 2 meters per second. And whereas grey is moving with a speed of 1 meters per second. And blue has already completed half the race on this 10 meters track. That is, it has already completed 5 meters. Now grey, the guy on the grey car, let's say you want to win this race. There is someone on the blue car. Then how much more speed? You already have 1 meters per second speed. How much more speed is required so that you can win this race? That's the question. See, a very simple way of doing such kind of problems is, this is 5 meters because blue car has already completed 5 meters. Okay. The blue car has already completed 5 meters. Okay. And now you need to know the how much time would be taken by the blue car to complete this race. More time. Like already 2.5 seconds has lapsed. Actually, if you have noticed it, if 5 meters has been completed by grey car, that means like 2.5 seconds has lapsed. So in how much time it will complete the entire race? In another 2.5 seconds. Okay. And that being said, like this grey car has to win the race. Now you are on urge to win this race. So how much speed your car needs to have? Now forget the tricky part, how much more speed or how much additional speed. So if things like this are given, notice them. But while solving the problem, first find out what should be your speed to win this game. So you know that you are 7.5 meters away from this place. Because you are traveling at 1 meters per second. And only 2.5 seconds has lapsed because grey car has completed half the race, which takes 2.5 seconds. And only 2.5 seconds has lapsed and you have only completed 2.5 meters. Now there is remaining 7.5 meters which you need to accomplish before blue. So the concept is about speed. You need to accomplish the 7.5 meters before blue. Then you need to have that certain velocity boost so that you can win this race. So if I have to complete 7.5 meters within 2.5 seconds, what's the speed that I need? Okay, and that too before blue car. So that would be 7.5 meters by 2.5 seconds. 3 meters per second. I should have something more than 3 meters per second, like 4 meters per second or 3.5 meters per second to win this race. Because still the blue car is constantly traveling with 2 meters per second. But I can still win this race if I have like 3 meters per second or 4 meters per second. I mean something more than 3 meters per second. Okay. So let's again have a look at it step by step. And we'll understand how to solve this problem. So the distance left for blue is 5 meters per second. So the blue car is 5 meter. So the distance left for blue car is 5 meters. So the blue car is away from the end point by 5 meters. whereas the grey car is away by 7.5 meters. Okay. So the time left for completing this race is 2.5 seconds. Already 2.5 seconds have lapsed. So the time left for completing the race, the another 5 minutes is 2.5 seconds. Now the speed required would be 7.5 by 2.5, something greater than 7.5 by 2.5. Speed of B required by Gray. So it should be like speed required by Gray. Okay guys, there should be speed required by Gray. Speed by Gray or speed required by Gray. And the speed required by Gray to win this race. So that should be 7.5 by 2.5. That would tell me what should be the speed of the Gray car to win this race. That is going to be greater than 3 meters per second. And what is the additional speed? You yourself on the car were already having 1 meters per second. Now you would subtract the 3 meters per second from 1 meters per second to solve the tricky part of the problem. So what do? You subtract the 3 meters per second from 1 meters per second. So you need an additional speed or an increase in speed of 2 meters per second. Okay. This is a very easy question, guys. You understood this, and now using this, we will derive the entire, relative velocity concept. We'll validate our assumption, what we are talking about, how do we work around relative motion. So that will be clear by the end of this problem. So let's say you have a velocity that is more than 3 meters per second and you won the race. Like in 4 meters per second, you just won the race. It was as easy as that. You had a more of like 2 meters per second added to your initial velocity or something like that. So now let's validate our assumptions. So by 2.5 seconds, blue had overtaken gray by 2.5 meters. Okay. Now I'm just going to explain the concept of relative distance and relative velocity, and then we will be deriving it. So with respect to gray car, blue is moving at plus 1 meters per second. So this blue car over here, is moving at an extra 1 meters per second, because blue car is traveling at 2 meters per second, whereas your car is traveling with 1 meters per second. Now this also means that every second the blue car is going to cover additional 1 meter. Isn't it true? So let's say you are moving at 1 meters per second, the blue car is moving at 2 meters per second. So whenever you observe it, you will see that the blue car with every 1 second is moving 1 meter away from you. If you are stationary, you would observe 2 meters, but if you are moving with some 1 meters per second speed, then you would observe as if this blue car is also moving with 1 meters per second, like away from you. Okay. So that let's now, solve this relative motion thing. Like I directly told you now, it is 1 meters per second. Why should you agree with me? We need a proof. We'll work around that. So now let's do a thing. We know all the parameters for 2.5 seconds. We'll now derive it for 3 seconds or calculate it for 3 seconds and derive the relative speed concept or the relative speed, result. So at 3 seconds, blue car would have covered 6 meters, which is correct, whereas the grey car would have covered only 3 meters. So the distance difference between would be 3 meters, whereas in the earlier case it was 2.5 meters. Okay. Okay. So that would be 2.5 meters. We know from the earlier calculation that the distance between the grey car and the blue car is 0.5 meters, isn't it? Like at 2.5 second, it has covered, 2.5 meters, and whereas the blue car would have covered 6 meters. The initial distance difference between them was 2.5 meters. Now this distance difference between them had grown to 3 meters. Okay, so the distance difference themselves had grown by 0.5 meters within 0.5 seconds. What does this mean? So you are seeing that car growing 0.5 meters with every 0.5 second, means that car is moving with 1 meters per second. Okay guys. Okay. So here what they are trying to say is, like the time difference, the distance difference between these two cars had become 3 meters and the time lapsed is 3 seconds, which means the car is moving 1 meter additional with every second, because the speed has to be like 1 meters per second for the distance between these two cars to grow by 3 meters. And the same thing can be done on the other way around, like what we just spoke. The distance difference between, the distance between the grey car and blue car was at 2.5th second was anywhere around 2.5 meters, whereas around 3rd second it was 3 meters. And now we know that the difference between these two distance differences is 0.5 meters. So the difference between these two different time distance, time distance, I am saying that because this different distances at different time was 0.5 meters. Okay, so this is the difference between these two. These two is going to be how much? That is going to be 0.5 meters. Isn't it, guys? This is just 0.5 meters. Okay, at 2.5 second, it was 2.5 meters away. At the 3rd second, they are 3 meters away. The distance difference between them at these two different times have grown by 0.5 meters. And the time difference between them is again 0.5 seconds. Okay, the time difference between them is 0.5 seconds. Now, if you do a little bit of math, we know that it is like 0.5 seconds distance difference, and the time difference is 0.5 seconds. Sorry, 0.5 meters is the distance difference. The 0.5 seconds is the time difference. That would tell me that the speed difference is 1 meters per second, distance by total time, or distance by time. So the distance difference is 0.5 meters and the time difference is 0.5 seconds. That would tell me that the speed difference is 0.5 by 0.5, which is 1 meters per second. So our assumption was validated, where I just took up, without, explicitly talking about anything. I told that, the speed is like the blue car is moving with respect to grey car at 1 meters per second. Now we've just validated our assumption. And you know what? Now let's, do this problem using the concept of relative velocity or relative speed or relative motion. So the distance difference between them to end this race, the distance difference between blue and grey car is 2.5 meters and 2.5 seconds is left to end this race. Okay, this was the earlier thing that we know. Okay, that there was 2.5 meters distance between them and 2.5 seconds is left to end the race, because this blue car is traveling at 2 meters per second and the leftover distance is only 5 meters. It has already completed 5 meters. And this leftover distance is only 5 meters, which means it has to complete this, which means it is going to complete this race with the next 2.5 seconds. Now, using the speed differences, we'll calculate this problem. Okay. Now, what I'm going to say, just forget that picture, just listen to me, be attentive, guys. So, to solve this problem, I have a very simple method. When blue car is at 5 meters, I know that 2.5 seconds has lapsed. When 2.5 seconds has lapsed, the distance difference between the blue car and the grey car is 2.5 meters. Okay. And the speed difference is 1 meters per second. So grey car would observe that blue car is always moving with 1 meters per second, or grey car is moving with an additional 1 meters per second. And Let's say now what I would do is to simply know what is the velocity needed by grey car at that moment to win this race. I would do a very simple thing. First, I would imagine myself, or you should imagine yourself in that grey car, and then think that you know already that the person in the blue car is moving with 2 meters per second. You need to assume that you are also moving with 2 meters per second. Now both of you are moving with same speed. That means these 2.5 meters distance between you both are not going to grow, or it's not going to become longer. Now when I know that these difference is not going to grow longer when I'm going to travel at the same speed, I know that I should travel with certain more speed so that I'm able to cover this 2.5 meters within that time left to complete the race to win this race. Okay, the time left to complete the race is 2.5 seconds. The distance between you both when you have the same velocity is 2.5 meters until the end of the race. Now divide this 2.5 meters by 2.5 seconds. Then an additional 1 meters per second is needed. The additional 1 meters per second is needed when you or myself is moving on this grey car with 2 meters per second, that is the same speed as blue car. So that would be 3 meters per second. But at 3 meters per second, you both would end the race at the same time. You're still not overtaking or winning the race. So to win the race, you need more than that additional 1 meters per second, or more than total of 3 meters per second. Wasn't it simple? Wasn't it simple than deriving initially that what is the time and then dividing the time? Rather, I just keep myself on that same speed and I imagine that this distance is not growing and the time left to complete the race is 2.5 seconds. I know I need some additional velocity because within the next 2.5 seconds the race is going to get over. I need to make sure I overtake this person on the other car. Then I need certain constant, like we are talking about constant speed problems or constant velocity problems. So I know that within this 2.5 seconds, I need to have certain velocity such that I cover this distance and overtake this person. And the distance difference was 2.5 meters. I divided it by the time left to complete the race. That was 2.5 seconds. So it was additional 1 meters per second, above which, above which the 2 meters per second. So that's going to be more than 3 meters per second to win the race. Okay, guys. So what is being said in this, document is using the speed difference between differences 1 meters per second for another 2.5 seconds. We know that the distance difference between the cars are going to grow by 2.5 meters within next by another 2.5 seconds or by another 2.5. Okay. So the distance difference initially was 2.5 meters and 2.5 seconds is left to end the race. Okay. At this position, the distance difference was 2.5 meters. And now I also know that the speed difference using the relative speed or velocity concept, that the blue car is moving at 1 meters per second additional speed or 1 meters per second speed difference for another 2.5 seconds. This also tells me that the distance between these two cars, that is within the time left to complete the race, is going to grow by another 2.5 meters. So the total difference at the end of the race is going to be 5 meters. Okay. Now, so this is basically the concept that I'm saying. So this was talking about the situation that would end up even if there is a relative velocity and nothing is being done. So this is the concept that I was talking about. So now in this concept, what did you do is you would equate the velocities, just like what we spoke. Okay. Like we'll be assuming these both cars are moving with same speed. Even though you are moving at 1 meters per second, you need some additional velocity to win the game. But now you have to just calculate it faster. You're just assuming both of you are moving with same speed. And the distance difference between them is like 2.5 meters. That means the speed difference between both of you, yourself and the blue car is 0. But there is always going to be a constant distance difference between both of you, that is 2.5 meters. Now what would you do is, the time left to complete the race is 2.5 seconds. Okay. And the constant distance difference between you both is 2.5 meters. So how much speed more is needed? Like how much additional speed is required by you when you are moving with the same speed as blue to win this race? So that would be 2.5 by 2.5. 2.5 meters by 2.5. So additional relative velocity required is 1 meters per second. Okay. So this would be like 2 meters per second plus 1 meters per second, something greater than 3 meters per second. You are winning the race. Okay. So you are winning the race when you have additional 2 meters per second. Total boost of additional 2 meters per second. Okay. It was really that simple, guys. This was really that simple. Now we'll work on a problem on a relative motion that is in opposite directions. Okay. Now in this case, there is this blue car on a green line. Let's assume it's exactly on the green line. And there is a grey car on the red line. They are going to move with opposite directions with a speed of 1 meter per second, 1 meter per second. So both of them have 1 meter per second speed, but in the opposite direction. So they have same magnitude of velocity, but in the velocities are in the reverse directions. Okay, and they are moving towards each other. Okay. Now the question is being asked is, when will both these cars cross each other? The grey car and blue car are moving towards each other in opposite direction. Okay, this should be like they are moving towards each other. Okay, they are moving towards each other at a speed of 1 meters per second and 1 meters per second. Equal speed, equal magnitude of velocity, but opposite velocities. But in opposite direction on a track. So they are moving on the same track. This itself tells us that they are on the same track. That is, the track is 10 meters. Now I need to know at what time these both cars will meet. I know most of you know the answers very intuitively, but let's work around the problem. So let's say after 1 second, I see that both of these cars have commuted like 1 meter away from the starting point. For blue, it is 1 meter away from the green, and for red, 1 meter away, for the grey, it's 1 meter away from the red. So after 1 second, what happened was, both these distances reduced by 1 meter. Actually, from the starting point for these two cars, but actually for both these cars, when they are moving when they are moving towards each other, the distance has reduced by 2 meters, because this has completed 1 meter and this car has already completed 1 meter. So in this track, we absorb 2 meters and the leftover length is 8 meters. The track has total length of 8 meters still left over. But these guys are going to meet at certain time. So 2 meters has been completed. The distance between them reduced by 2 meters. The distance between grey and the blue car has reduced by 1 meter. Sorry, 2 meters. 2 meters. 2 meters. Okay. And the grey traveled 1 meter. So did the blue. Okay. So this is just we are perceiving the problem after 1 second. What is happening? After 1 second, the distance difference between these two cars reduced by 2 meters. And now the total distance left on the track, that is the distance left on the track, I mean by over here, is the distance between these two cars. Okay. The distance between these two cars is going to be 8 meters. Okay guys. So the distance difference between them is going to be 8 meters. Now, the total time it had taken so far to reduce 2 meters is 1 second. Isn't it? Both this car commuted 1 second, but only 1 second has lapsed. With respect to, any observer or anything, only 1 second has lapsed. That means these two cars distances decreased by 2 meters with a lapse of 1 second. Then the relative speed is 2 meters per second. Okay, the relative speed between those two is 2 meters per second. So guys, this should be 1 meter. Okay, 1 second, I mean. This should be 1 second. Okay, so that would be 2 meters per second. That being said, when will they meet? If it is 2 meters per second and you have to complete 10 meters, what's the time? 5 seconds. At the 5th second, both of them will meet. So it's also intuitive, right? Like you don't have to, like, it's a simple problem, so you can just guess it, you know, without even looking at anything. So you will say at 5th second, this car would have approached this 5 second, this 5 meters. Okay, before this, like you would say, this car would have traveled 5 seconds. Okay, 5 meters, I mean. In 5 seconds, it will cover 5 meters. And this car is also moving at 1 meters per second. This car would also cover 5 meters. Okay. And the total, you know, time at which, the time at which they are going to meet is 5 seconds. But the speeds are equal. But see in this case, guys, how easy the problem had become. Initially, you had to find out it was going to be 5 meters. And this is going to be 5 meters at 5 seconds. So you would have to calculate this problem with at least 5 steps. Now using this relative speed concept, we can solve this problem in 2 steps. You know the relative speed between the both is 2 meters per second. The relative speed is going to be 2 meters per second since they are moving towards each other. And the total length of the track is 10 meters per second. So the total length of track is 10 meters. And the relative speed is 2 meters per second. That means the total time needed is 5 seconds. The total time needed is 5 seconds, and within this 5 seconds, they will meet. Wasn't this simple? I'll go through this problem again. I guess even, I have made a lot of blunder around, spellings and things like that. I'll go through this problem again very quickly without, just going through all these concepts of, just saying what is a second, what is this, and what is all of these things. So the idea is to understand relative velocity. Now when the cars are approaching each other or moving towards each other. Now they have 10 meters difference between these both. Okay. And they both are moving with 1 meters per second towards each other. So the question being asked is, when would these two cars exactly meet? Assume they are like point objects. Don't assume they are a car with a length. If they are given you a length, account that length into the problem. Okay, if the length of the car is given, account that into the problem. Now what I can simply do is, since this is moving with 1 meters per second and this is moving with 1 meters per second and they are approaching each other, I know the relative speed is 2 meters per second. And the distance difference between these two cars are 10 meters. Okay, so the relative distance is 10 meters. The difference between these two positions is 10 meters. The velocity is 2 meters per second. Okay, now I will have to divide this 10 meters by 2 meters. Sorry, 2 meters per second. Then I find out at 5th second they will meet. It is really that simple. Okay, or else what you can do is you can calculate after 1 meter what has happened. So you'll observe that these two cars have reduced the distances or the distance difference between them by 2 meters. And then you will divide this 2 meters by 1 second. That is after 1 second. What happened? So you will see that the relative velocity is 2 meters per second. And within the next 5th second, within the next 4 seconds or in the 5th second, these both cars will meet. It was really that simple, guys. Now let's understand this relative motion concept, with like a stationary observer or if the observer is moving or something like this. So in this case, let's say that this is you observing these cars moving. Okay. You will pretty intuitively see that these cars are moving. Okay. The black car is moving in the downward direction, whereas the blue and the grey car is moving in the upward direction. Whereas the grey car was moving with more speed and the blue car was moving with lesser speed. Okay. You see that black car is moving in the downward direction, grey car is moving in the same direction as the blue car, whereas the grey car is moving slower than the blue car. Now, what if you two are the only people over here? Okay, you are a stationary observer. Okay, you are a stationary observer who's trying to determine the speed of this car. Okay, you are trying to determine speed of this car. Okay, you have some sort of gadget. You are trying to determine the speed of this car. And now, what you are trying to do over here is you are trying to observe him or observe that car. And you see that the car is moving with 10 meters per second. But the person in the car, imagine there was some other stationary observer you are trying to observe from the car. You are also approaching that person with 10 km per hour. But you are, as an observer inside the car, assume that you are not moving. Just like the bus problem. Or in this case, you will see that you are stationary. You will think that you are stationary. But you will see that that person is approaching you with 10 km per hour speed. Okay guys. Do you understand that? Forget the smartness of your brain. But think about it as someone observing it from the third frame of reference. Or like another frame of reference. Where that frame of reference itself is moving with 10 km per hour. Imagine this car as big as Earth. Then you would see that that person is moving towards you, not as if you are moving towards that person. Okay. So what about if two cars are moving towards each other but in opposite direction, like the problem before? So in that case, each car was seeing that they are approaching each other with 2 meters per second speed. Okay. Let's say in this case, black with respect to a stationary observer is moving at 10 kilometers per hour. And blue is moving at 10 kilometers per hour with respect to a stationary observer, but in the opposite direction. Then in that case, blue would notice the black car as moving with 10 km per hour towards it. And similarly, black would see as if the blue car, see this is done in blue. Okay, so that you understand the concept better. So now the thing is, this person, the black car, would see the things like see this blue car as if this blue car moving with 20 km per hour. Because it would see as if that car is approaching it with 20 km per hour. Think about it as two planets moving towards each other rather than, car, then this concept would become obvious. And once they cross each other, they would see minus 20 km per hour. They are moving from each other with 20 km per hour speed, but in the opposite direction. This is critical, guys. You need to understand this concept. Okay. Now the thing is, let's say there are two objects or two cars moving in the same direction. Gray is moving with a larger speed, 20 km per hour, and blue is moving at 10 km per hour. Now what would happen? Let's see. Okay. So now you would see that, blue car is going to see as if that the grey car is moving away from it with 10 km per hour speed. Whereas the person sitting in the grey earth or the grey car is going to see that the blue car is moving 10 km per hour in the reverse direction, or it is moving away from it with 10 km per hour speed. Guys, did you get this concept? I'll just play this, graphics again. So you would see that the person is like, the person in the blue car would see as if the grey car is moving away 10 kilometers. Whereas the person in the blue car would see, the person in the blue car would see that the grey car is moving away with 10 kilometers per hour speed. Whereas the person in the grey car would see that the blue car is moving away with 10 kilometers per hour. Okay. The person in the grey car would see that the blue car is moving away from it. Okay guys. So the person in the grey car would observe that the blue car, the blue car is moving away from it with minus 10 km. I mean, moving away from it with 10 km per hour, that is minus 10 km per hour. Whereas blue car would see as if that the grey car person is moving with 10 km per hour distance. Whereas the distance difference between them is growing with 10 km with every hour. So this is the concept, guys. You need to imbibe and absorb this concept. It's very easy. Okay. Now we'll talk about frame of reference. Okay. So in this case, let's assume that this, this person C is us, and we are going to observe this person A. So we are going to make use of some Doppler machine or something to measure the speed of A. And we are standing on a stationary platform, like a platform that is not moving with any speed. Okay. So in that case, what would happen? What is the speed of the person A that you are going to observe? So it is saying that the person A is moving on the train. So that person A is moving on the train with 10 meters per second speed, and the train itself is moving with 30 meters per second. Then find the relative velocity of A with respect to C. Okay. So it is talking about relative velocity with respect to C, of A with respect to C. Okay. So what is the speed that if C as, let's say, a radar gun or like a Doppler gun with which it is assessing speed. Let's say we are standing on the stationary platform and we are assessing the speed of this person A who is moving on the train with 10 meters per second, where the train itself is moving with 30 meters per second, and we are measuring with this gun. Then what would the speed that we see? We would see that this person A is moving with a speed of 40 meters per second. Okay guys, we would observe that this person is moving with 40 meters per second speed. Okay, it's really that simple. Because it is 30 plus 10. You'd add both of these quantities because the frame of reference itself is moving with 30 meters per second, whereas you are standing on a stationary frame of reference. And then this person is again moving with 10 meters per second. So you would see as if the person is moving with 40 meters per second. In this direction, of course. Okay, we're talking about velocity. So in this direction. In this direction. Okay. Now we'll just simulate in axes, in 3 axes, or in 3D direction, how these frame of references, if they are moving towards each other, are going to behave. So let's say now these 2 frame of references, that is these 2 axes, this black axis and this blue axis, are moving towards each other. Then what would it look like? Okay, they would look like as if they're approaching each other with certain velocity, but this velocity would be applicable for all 3 axes. When they are moving towards each other, you would see that these velocities are applicable for all 3 axes. In this case, they are appearing as if they are parallel. So you don't mind, you'll just observe the same velocity along y-axis and z-axis. But let's say they are tilted direction, then the y velocity will also change, z velocity will also change. In this case, since they are parallel, you will be seeing these 2 axes have same velocity. And in the case where they are moving away from each other, you'll see that the distance is growing, isn't it? Initially they were over here at this point, let's say this is the midpoint. Now once they started moving away from each other, the distance is growing. So the distance is becoming bigger between these 2. Okay, so the distance has finally become something like this, like the displacement, or the distance between these 2 axes have grown larger. Whereas in this case the distance has reduced, and you'll see as if they have move towards each other. And you would do it for pretty much everything, every velocity, any kinematic property or even dynamic property. You would take it according to the frame of reference. The frame of reference can be any one of them. It can be this one as be the frame of reference, or this one can be the frame of reference. Accordingly, x, y, z will change. So that was just a simulation. So what about the applications? We have been talking about frame of reference, etc. Blah, 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 relative velocity. Is it really, a concept that we use every day? Is it something that we are seeing everywhere? Of course, we are seeing it everywhere. So when we are talking about frame of reference and relative motion, it is used in satellite, guys. Your GPS is also assessing relative motion and frame of reference. The satellites are seeing relative motion and frame of reference. And another interesting thing, your police is noticing the speed with a radar gun which is using relative motion, Doppler effect. The radar guns are making use of Doppler effects. And have you ever noticed that the antennas are able to sense the speed of like flights? It is using the frame of reference and relative motion concept. They are continuously emitting the waves, they are measuring the reflected waves, and they see the change in the speed. And using that, they are able to assess that this flight is approaching me with so and so speed, or this flight is approaching this, the space or the sky with certain speed. Okay, guys, these are some interesting applications. But we need to understand few things, like before we conclude with this topic, we need to understand few conceptual things. Really, really important concept, guys. Really, really important. Not just important, very interesting concept. Okay. First one is going to be inertial frame of reference. So what is an inertial frame of reference? Inertial frame of reference is one where the frame of reference, let's say you're standing on a train, the train is moving with some velocity or not at all moving. Then this train is called inertial frame of reference. And in this inertial frame of reference, the Newton first law comes into the play. If you skip that force part, it says that a body in rest will be always be in rest, or a body in motion will always be in motion. So an inertial frame of reference is one where the frame of reference is either moving with constant velocity or it is not at all moving. There is no force on it. That is inertial frame of reference. Examples would be you sitting in your home. Your home is not moving according to you. Okay. Even though there is a gravitational force, you just ignore that gravitational force. You just imagine yourself, your home is located in some space where there are no masses. And in that case, your home would be your inertial frame of reference. And similarly, a person standing on a train and the train is moving with some velocity like what we saw earlier, and in that case, what is the frame of reference? Let's assume you are the person A. Okay, according to you, the frame of reference is the train, and you would remain in the 10 meters per second velocity forever unless a force is applied on you. Okay, that is inertial frame of reference. What about non-inertial frame of reference? Exact opposite of inertial frame of reference. In this case, the frame is under acceleration. The frame is maybe under some force. For an example, our Earth. Our Earth is a non-inertial frame of reference. We have a gravity acting on us. The Earth is rotating. The Earth itself is rotating, which means the velocity is changing. It's not a constant velocity. So, it is a non-inertial frame of reference. You got this point, I guess. So, a non-inertial frame of reference is one where the frame of reference is under acceleration or the velocity is changing. And one other good example of non-inertial frame of reference is if you observe a car, moving on a semicircular path with constant speed. Let's say the car is moving constant speed, then the person in that car is seeing as if you are changing your velocity. Okay. And that car is that non-inertial frame of reference. Okay, guys. So let's say a car moving on a semicircular path with constant speed. In that case, that car is known as non-inertial frame of reference, and that car would observe a person, a stationary person standing outside, as if that person is, moving with certain acceleration. So now let's come to the standardized formula. The standardized formula for working around relative speeds, relative velocities and frame of reference problems. Okay. So let's say you are in the frame of reference, then you would simply add the velocity of frame of reference to your velocity. So you would basically add the speed or velocities to your speed. I mean, to your speed you will add the frame of reference speed. And let's say the frame of reference is outside you. Okay, and you have to assess the speed with respect to that frame of reference. Or you are the frame of reference and you are trying to observe an object. Then what you would do is you will subtract the velocity or the speed of that object from the frame of reference object or the frame of reference or even that object. So if you are moving towards each other, you will add them, and if you are moving away from each other, you will subtract them, or even if you are moving away means this also means you are moving away from each other. Then in that case you will add them and you will add a negative sign. Okay, the third condition is not discussed over here. So in the third condition, what you would do is you would add both of these velocities and add a negative sign. I mean, put a negative sign in front of it. When these two objects are moving towards each other, you will add the velocity. When these two objects are moving away from each other, you will subtract them. This should be clear, guys. And one other thing, please don't go by the standardized formulas. Try to solve the problem. Try to understand what the problem is asking you. In frame of reference, relative motion, don't go by the formulas. Go by the concept. If you go by the concept, things are very easy. If you go by the formula, you are messing either with sign or you are messing either with the formula itself. Sometimes the formula may not work. You never know. And what is the standardized definition of rest and motion? So an object is in rest if the object is not moving in its position. Okay, for an observer, if the object is not moving in position, or for the surrounding, if the object is not moving in the position with time, then it is called rest. And the motion is the exact opposite thing of it. So an object is in motion if that object is moving in time with position, or in time the object's position is changing, then you would say that this object is moving. Okay. Simply for a motion, you would say that if the object is moving in position with time, then you would say that this object is in motion. This definition is clear to you, I guess. It's a very easy definition, still a definition, but you understood the concept, which is more important. And similarly for relative motion, you understood the concept. So we'll do more problems on this relative motion to understand them better. So now there is a question. The grey car and blue car are moving in opposite direction at a speed of 10 meters per second. Okay. The grey car and blue car are moving in opposite direction at a speed of 10 meters per second and 15 meters per second. So both these cars are moving. One of the car is moving at 10 meters per second. Which should be that one? That would be grey car, because the term respectively is used. So the grey car is moving at 10 meters per second and the blue car is moving at 15 meters per second, but in opposite direction on a 100 meters track. So this is like the last problem that we saw, where both the cars are moving at 1 meters per second, which was little easy, and the track was only 10 meters. But in this case, they are moving with different speeds and in fact even different velocities. And the grey car is moving with 10 meters per second. I'll do a thing, I'll highlight the grey car thing with, I'll just erase all the annotations on this and I'll draw this grey car and its speed. I'll highlight this grey car and its speed with green marker. Okay. And I'll make use of some blue marker for blue car. Okay. This blue car is moving at 15 meters per second. I guess this is hiding, but you still understood it. So it's 10 meters and 15 meters per second. And they are moving in opposite direction and they are moving in a track with 100 meters length. Now we need to find out when will both these cars cross and at what position from the green line. So probably they are also asking you at what position from the green line this blue car is going to be. Okay. Simple guys, simple. Relative velocity 25 meters per second. Relative length 100 meters. Divide them. Divide this total length by relative velocity. So within 4 seconds they are meeting each other. So within 4 seconds, how much distance has this blue car traveled? When it's traveling with 15 meters per second, 60 meters. It's really that simple, guys. And guys, I hope you understood this problem. We'll do more of this problem. And kill your ego, else your ego will kill you. Don't memorize the concepts. Kill your ego, kill your ego, kill your ego. Don't cheat yourself. Kill your ego, else the ego will kill you. Value love. You have to give the utmost value to the love or the person who loves you. And keep smiling, guys. Keep smiling. Smile helps you better. Smile helps you perform better. If you're happy, you perform better. And ignore gossips, especially at this time. If you're preparing for exam, you're in 2020 rush, then ignore gossips. Ignore what people say about you. Ignore what is happening. Give your best. Try to do your best. And for success, you have to achieve it. To achieve it, you have to work hard. And knowledge, guys, share it and acquire it, and rather acquire it and share it, or else you can do it the other way as well. Share it and acquire it. You can brainstorm with your friends. You can sit along with your friends, watch the video, and then you know what? You can do it better. Share it, guys. Share the knowledge. Just don't keep the knowledge to yourself. And guys, you can download our Unacademy app on App Store or Play Store, and you can attend our free live classes or free special classes with our top-notch educators. Or else, if you're looking for some test series or live sessions or doubt clearing sessions, you can go to our Unacademy app and subscribe to our JEE. If you're looking specifically for JEE or NEET or WIT, whatever you're looking for, if you have that option, just go and pursue that option. And if you're looking for some coupon, you can make use of Murli Live, and you know what to do if you're in 10th or 9th class, or if you're long-term or dropout, or if you're looking for some immediate remedy. That's it, guys. Stay safe, stay tuned, enjoy the classes, understand the concepts. Do comment below if you didn't understand the concepts, and do try to understand it. Do try to watch the video again and again. This is one of the topics where you'll be getting most of your problems. This, one would be average speed, one would be your relative motion concepts or frame of reference concepts, or it would be some graphs that we'll be looking in the future classes. We'll do more on relative motion. Don't worry, guys. I think this concept will become clear by the end of the next class. We'll solve some IIT JEE problems and some problems that have appeared before. Alright, guys. Take care. Stay safe. Enjoy learning.